Hello, this is Ganga Bhavani, Assistant Professor in EC Department of IARE. Today we shall discuss a problem solving on electrical analogous of mechanical translational systems. So if a mechanical translational system is given, how to draw its equivalent electrical circuit, we shall see today. Okay, so let me take this problem where a mechanical translation system is given in which you have two mass elements M1 and M2, and each one is attached to dashboards and springs. Okay, so we shall see how to draw its electrical equivalent and at the same time how to derive its transfer function also. Right. So first, if we start writing for mass 1, see the same problem figure is given here. Let me write equation for mass 1, M1 element. Okay. So what are the forces acting on M1? Forces acting on M1 are due to the dashboard B1 and spring K1 and apply force F. Okay. And displacement of this mass M1 is taken as X1. So as per Newton's law, we can write F equal to Fm1 plus Fp1 plus Fk1. Okay. So F is equal to, and Fm is given, Fm1 is given as opposing force due to the mass element is written as m1 mass into acceleration, that is m1 into d square x1 by dt square. Okay, plus, and b1 dashpot, since it is present in between both the elements m1 and m2, and for opposing force due to dashpot is written as b into velocity, so b1 into dx by dt, but d by dt, and coming to displacement, here it is taken as x1 minus x2. X1 minus x2 plus Fk1, and force, opposing force due to the spring is given as k into x, and now k1, and here again k1 is common between both the elements and m1 and m2, so k1 into displacement, corresponding displacement is taken as x1 minus x2. Okay, that is how equation of motion for mass m1 is given by m1 into d square x1 by dt square plus b1 into d by dt of x1 minus x2 plus k1 into x1 minus x2. Similarly, next we will see how to write for this mass element m2. Okay, so for this mass element m2, if you observe, what are all the forces acting upon m2 here? You have two dashboards b1, b2 and two springs k1 and k2, and also opposing force due to mass element. Right. So sum of all these forces will be equal to 0. That is Fm2 plus Fb1 plus Fb2 plus Fk1 plus Fk2. Okay. So sum of all these forces should be equal to 0. Coming to Fm2. Fm2. What is Fm2? Fm2 is equal to mass into acceleration. So m2 into d square x2 by dt square. Okay. Coming to Fb2. How about Fb2? It is attached only to mass element B2, mass element M2. So we write it as Fb2 equal to B2 into velocity. The velocity, what is velocity? dx2 by dt. Right. Similarly, Fk2. Fk2 equal to K2 into x2. K into displacement. So K2 into x2. Then how about Fb1? Fb1. Now again B1 is existing between the two mass elements m1 and m2, but now displacement is x2 minus x1. So Fb1 will be what? B1 into d by dt of, what is the net displacement here? x2 minus x1 plus, and what else? Other Fk1. How about Fk1? Fk1 is k into displacement. So k into net displacement is x2 minus x1. So sum of all these 5 forces is equal to 0. That is how you get equation of motion. Equation of motion for mass m2 is given as m2 into d square x2 by dt square plus b2 into dx2 by dt plus b1 into d by dt of x2 minus x1 plus k2 into dx2 by k2 into x2 plus k1 into x2 minus x1. So sum of all these forces is equal to 0. So from equations 1 and 2, we have this. That is from equation of motion for mass element m1 and equation of motion for mass element m2. You can write these two equations like this, right? So now, coming to how do you draw its electrical equivalent, we have seen in the earlier classes that a mass element, when you're trying to draw, this is force voltage analogous circuit. So while drawing force voltage analogous circuit, L, that is ML, mass element is equivalent to inductor, okay, and dashpot is equivalent to resistor, and spring element is equivalent to 1 by C. Okay, 1 by C. We have seen this electrical equivalent of mechanical translational systems in force voltage analogy and force current analogy. Okay. Now, so M1 and corresponding, and similarly displacement in mechanical translational system is equivalent to velocity dx by dt is equivalent to current I in the electrical equivalent. Okay. So when you are trying to draw the electrical analogous circuit of a mechanical translational system, mass element is replaced by inductor, dashpot is replaced by resistor, spring is replaced by a capacitor, and velocity, that is dx by dt, velocity is replaced by I. This is in case of force voltage analogous circuit. Okay. So look here. Now, if we observe this, M1 into d square x1 by dt square. So if dx by dt is analogous to I, then d square x by dt square will be analogous to di by dt. That is how. So we can write its equivalent like this. L1 into di1 by dt plus B1. B1 is nothing but R. So R1 into dx by dt is nothing but I. So R1 into I1 minus I2 plus K1 into, when dx by dt is I, then x will be equal to integral I. So it is K1. So what is K1 equal to? Equivalent to 1 by C. So it is 1 by C1 integral of I1 minus I2. Okay. Equal to, force is analogous to voltage. Okay. So this is V. Right. So now we have to draw the electrical circuit which represents this equation. And similarly, second equation also we can write it as L2 into di2 by dt plus B2 is nothing but R2. So R2 into dx2 by dt is I2. So it is R2 into I2 plus B1 into B1 is equal to R1. So plus R1 into I2 minus I1 plus K2 is 1 by C and X2 is integral I. So integral I2. So 1 by C2 integral I2. Then plus K1 is 1 by C1 integral of I2 minus I1 equal to 0. So now these two equations we have to draw an electrical circuit which satisfies these two equations. Okay. So first if you see L1 into di1 by dt. So first let me place mass element M1, that is nothing but its electrical equivalent is inductor in force voltage analogy. So you have an inductor L1 and L2. Okay. So if you observe, what are the elements that have common both I1 and I2 in common? You can see here it is R1 and C1. Right. So here it is R1, I1 minus I2, C1 integral I1 minus I2. Similarly here R1 I2 minus I1 and 1 by C1 I2 minus I1. So a current I1 and I2 both flow through the branch of R1 and C1. So here replaced R1 and C1 common to both, that is which is common to both the loops having currents I1 and I2. Okay. And what all other elements carrying current I1? This is only R1, M1 and C1. R1, M1 and L1, R1 and C1. Coming to I2 current we can find in L2, R2 as well as K2. So L2, R2 and C2. So all these three elements will come in series. So current I1 flows through this loop and current I2 flows through this loop, and both the currents I1 and I2 flow through this branch R1 and C1. That is, R1 and C1 are common to both the loops. So accordingly, from these two equations, we draw its electrical equivalent circuit in this form. So mass equivalent is inductor, dashpot equivalent is resistor, and spring equivalent is capacitor. Okay. Then how about force current analogous circuit? Force current analogous circuit means in this case, force, that is source, is taken as current. So that is how we show current source here. And M dashpot is taken as 1 by R, that is conductance. Okay. Then mass element is replaced by capacitor. Mass element is replaced by capacitor. And K is replaced by mass element is capacitor. And spring is represented by K equal to 1 by L. Okay. So taking this notation, again if we go back to the two previous equations now, in place of F we can write I. Okay. So let me write those equations here. You have M1 d square x1 by M1 d square x1 by dt square plus B1 d by dt of x1 minus x2 plus k1 into x1 minus x2 is equal to F. And the second equation is M2 d square x by dt square plus B2 dx2 by dt plus k2 into x2 plus b1 into d by dt of x2 minus x1 plus k1 into x2 minus x1. Sum of all these forces is equal to 0. Right. So now we'll try to draw its equivalent in force current analogy. In force current analogy, as I told, force is replaced by current source, and now mass element is replaced by capacitor. Okay. And here now dx by dt, displacement is replaced by, in earlier case displacement, velocity was replaced by current. Here dx by dt, velocity will be replaced by voltage. Okay. So velocity will be replaced by voltage. So then how about d square x by dt square? D square x by dt square is replaced by dv by dt. Okay. So dv by dt. So if you write equivalent equations, so M C into d square x by dt, C dv by dt, C1 into dv1 by dt plus B1. B1 is equivalent to G, that is 1 by R. So 1 by R into dx1 by dt is V1, that is voltage V1. So V1 minus V2 plus K1 into, sorry, K1 is equivalent to 1 by L. So 1 by L, and x1 is nothing but integral of V. So 1 by L integral of V1 minus 1 by L into integral of V1 minus V2 equal to F. F is nothing but here current. Okay. So applied current I is equal to C dv1 by dt plus 1 by R into V1 minus V2 plus 1 by L into V1 integral of V1 minus V2. Similarly, we write the electrical equivalent of this equation, right? By replacing mass element by capacitor, spring by 1 by L, spring is nothing but 1 by L, and dashpot is 1 by R, that is conductance. So after writing the mathematical equations, now we try to represent in the figure. Same previous case we have written force voltage analogy. Now we'll draw it for force current. So we draw a circuit which satisfies these two equations. After replacing the after replacing the mechanical translational elements by the analogous electrical elements in force current analogy. Now, for the same system, if we try to write transfer function, earlier we have written equations 1 and 2. Once when you apply Laplace transform to those two equations, we get m1 d square x1 by dt square, because Laplace transform of, if Laplace transform of x of t is x of s, then Laplace transform of dx of t by dt is given by s into x of s with initial conditions 0. Similarly, integral x of t will be 1 by s into x of s. Then how about d square x by dt square? d square x of t by dt square, Laplace transform is given by s square into x of s. So taking these three, if you apply Laplace transforms to equations 1 and 2, you get these two. So m1 s square x1 of s plus b1 of s into x1 minus x2 plus k1 into x1 of s minus x2 of s. Since there you have dx1 by dt, so here we get s into x of s. Right. Similarly, for equation 2 also, if you apply Laplace transform, you get this equation 4. Now, from equations 3 and 4, transfer function, let me say I want to find the transfer function x1 of s by f of s. So, if you want to find x1 of s by f of s, we will try to eliminate this x2 from both the equations. Then, you will get equations only in terms of f and x1. Suppose you want to find the transfer function x2 of s by f of s. In such case, we will eliminate x1. Okay. So now since I am trying to find out x1 of s by f of s, eliminating x2 from equations 3 and 4. So solving for x2 in equation 4. So in equation 4, if I try to write expression for x2 of s, what do I get? x2 of s is equal to from this one. From this equation, what is x2 of s? x2 of s is equal to, take all the other terms on the other side. So we get x2 of s is equal to b1s plus k1 into x1 of s, b1s plus k1 into x1 of s minus m2s square minus b1 plus b2 into s. Okay. So k1 plus k2 into s is equal to this, or x2 of s is equal to this whole thing by x2 of s is equal to, this into x2 of s. So rearranging the terms from equation 4, you write expression for x2 of s, then substitute this x2 of s in equation 3. Then just replacing this x2 of s in equation 3, see here. So m1s square plus b1s plus k1, m1s square plus b1s, see this term, m1s square plus b1s plus k1 into x1 of s. So m1s square plus b1s plus k1 into x1 of s minus x2. So x2 from this equation minus b1s plus k1 into x2. b1s plus k1 into x2. What is x2? This factor is x2. b1s plus k1 by m2s square plus b1 plus b2 into s plus k1 plus k2 into x1. So substituting this x2 in equation 3, you get this equation. Now rearrange. Take x1 of s common in this equation. Take x1 of s common, and then after writing the equation, take all other terms on the other side. That is, try to extract the ratio x1 of s by f of s. That itself will give you the transfer function. Right. So this is how we draw the electrical analogous, that is force voltage analogous circuit and force current analogous circuit for a given mechanical translational system. And also how we find the transfer function by just applying Laplace transform to both the equations and then trying to extract the factor. That is whether you want to find x1 of s by f of s or x2 of s by f of s. Accordingly, we can derive the transfer function by eliminating the other variable. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.